Hello everyone. I welcome you all for online video tutorial by Department of Civil Engineering, Sai Vidya Institute of Technology. Myself, Professor Gautam, working as Assistant Professor in the Department of Civil Engineering. Today, I am going to teach how to calculate bearing capacity of the soils using Terzaghi's equation. I already given introduction about this in your previous class. Now let us take the problems on this. Yeah. So in the right tab, I just opened Terzaghi's bearing capacity equations for different footing. You can observe here, and for different type of soil. If it is a C5 soil, that means if the soil is having both cohesion and friction. For circular footing, this is the formula 1.3 C into N suffix C plus gamma D into N suffix Q plus 0.3 gamma B into N gamma. So in the circular footing, B stands for it is a diameter of the footing, where N suffix C, N suffix Q and N suffix gamma, it is a Terzaghi's bearing capacity factors. And for square footing, this is the formula. And for strip footing, this is the formula. And for rectangular footing, this is the formula. Okay, if you remember these formulas, easily you can solve the problem. By chance, if it is a cohesion-less soil, in all these formulas, you have to make C is equal to 0. Okay. Now, let us take the first problem. You can observe the problem in left tab of my screen. So the first problem is a square footing 2.8 meter into 2.8 meter is built on homogeneous bed of sand of density 18 kilonewton per meter cube and having phi value is equal to 36 degree. The depth of a foundation is 1.8 meter below the ground. Determine the safe load that can be applied on the footing with the factor of safety 2.5. Consider n suffix c is equal to 27, n suffix q is equal to 30, n suffix gamma is equal to 35 as bearing capacity for analysis. Okay. So whenever this problem will comes, first you have to see what type of footing it is. This is actually a square footing, right? Now, for the square footing, this is what type of soil you need to check. Okay, anyhow, for the square footing, this is the formula, right? 1.3 C into N suffix C plus gamma D into N suffix Q plus 0.4 gamma B into N gamma. See, I had written the same formula here. Q suffix F is equal to 1.3 C into N suffix C plus gamma D into N suffix Q plus 0.4 gamma into B into N gamma. In this formula, Q suffix X stands for ultimate bearing capacity of the soil for square footing. C stands for cohesion. Now let us see whether this data is available in the problem or not. Since it is a sand is a cohesionless soil, you can consider C value is equal to 0 because sand is a cohesionless soil, right? For the cohesionless soil, C is equal to 0. Now, gamma value he has given in the problem. Gamma is how much? 18 kilonewton per meter cube. So gamma value straight away he has given that 18 kilonewton per meter cube. Okay. Then he said that phi value is equal to 36 degree he has given. Then depth of foundation D value he has given, that is equal to 1.8 meter depth of foundation. Then determine the safe load that can be applied on the footing with the factor of safety. F value also he has given. Factor of safety is equal to 2.5, right? So factor of safety is 2.5 and remaining other values he had given. Now, see, all the values are available in this formula, right? Gamma is 18, D is 1.8, N suffix Q, he has said that it is 30. Then again gamma and B stands for, again it is an 2.8. There is a base of the footing, width of the footing 2.8. So you can substitute here. N gamma also he has given in the problem, it is 35. So solve for this and you are going to get ultimate bearing capacity of the soil is equal to 1677.6 kilonewton per meter square. Now, once ultimate bearing capacity is available, as I explained in our previous class, net ultimate bearing capacity is given by the formula Q suffix NF is equal to Q suffix F minus of gamma D. Q suffix F you had found in the previous step, that is 1677.6 kilonewton per meter square, minus gamma is 18 and depth is 1.8. You substitute here. Therefore, net ultimate bearing capacity is equal to how much? 1645.2 kilonewton per meter square. Okay, that is your net ultimate bearing capacity. Now, safe bearing capacity is the formula Q suffix S is equal to net ultimate bearing capacity divided by factor of safety plus gamma into D. And this is the formula for safe bearing capacity as I explained in your previous class. Okay. Now all the values are available. Q suffix NF, that is net ultimate bearing capacity, you had found in the previous step. So gamma is available 18 and the depth is available 1.8 and factor of safety he has given in the problem as 2.5. So substitute all the values and check what is the safe bearing capacity. That means safe bearing capacity of the soil is 690.48 kilonewton per meter square. Now, in order to calculate safe load, you can apply on the footing is Q suffix S, that is safe bearing capacity multiplied by area of the footing. So safe bearing capacity is how much? 690.48. And what is the area of the footing as given in the problem? You can see here it is 2.8 into 2.8. That is the area of the square footing. Therefore, you can apply a total load of the on the footing is how much? 5413.36 kilonewton. That means this much load you can apply on the footing. Okay. I hope all of you understood the first problem. Let us move to the second problem. The second problem is what will be the gross net bearing capacity? So here is asking net bearing capacity of sand having phi is equal to 36 degree and dry unit weight is 18 kilonewton per meter cube for the following cases. First case is 1.5 meter strip footing. Second, 1.5 into 1.5 meter square footing. Then 1.5 meter dia circular footing. The footings are placed at a depth of 1.5 meter from the ground surface. Assume factor of safety as 2.5. Use Terzaghi's bearing capacity equation and bearing capacity factors are given below. Okay. So here, first, let us try to understand the problem. See here, he is saying that he used three type of footing: strip footing, square footing, and circular footing. See, for if it is a circular footing, this is the formula we have to use. If it is a square footing, this is the formula we have to use. And if it is a strip footing, this is the formula we need to use. Okay. So all the formulas are available. Let us see the data what he had given. So he had given the gamma value as 18. So gamma value he has given, and B values for different footings it is available. See, 1.5 for strip footing, again 1.5 for square footing, and for circular footing B value, that is diameter, is 1.5 meters. So though, no problem, that is also available. B values are available for all the footing. So next, depth value. So it is 1.5 meter. Depth is 1.5 meter. So for all the cases, then he said that factor of safety is equal to how much? 2.5. So factor of safety is also available. Okay. Now let us take one by one. But the thing is here he is saying that phi value. See, phi value is 36 degree. So in the problem he had given the table for different phi values, what is n suffix c, n suffix q, and n suffix gamma values. So he had given it for phi values 35 and 40, but our phi value is 36 degree. You have to do the interpolation of 36 degree, considering 35 values, 35 degree values of nc, nq, and n gamma, and 40 degree values for nc, nq, and n gamma. You have to do the interpolation for phi is equal to 36 degree in order to calculate n suffix c, n suffix q, and n suffix gamma, that is Terzaghi's bearing capacity factor. So I had calculated n suffix c for 36 degree is 65.38, n suffix q is 49.38, and n suffix gamma is 54. So I did the interpolation. Now let us see the formulas for strip footing. Here you can see for strip footing. So this is the formula: c suffix nc into gamma d into n suffix q plus 0.5 gamma b and gamma. See, in the problem is said that it is a sand. For sand, you can consider c is equal to 0. If you do c is equal to 0, ultimate bearing capacity, you are having all other values. You just substitute here. The value of ultimate bearing capacity is 2062.26 kilonewton per meter square. Therefore, net ultimate bearing capacity is equal to ultimate bearing capacity minus of gamma into D. So gamma value you know, D value is no, Q suffix F value, that is ultimate bearing capacity you had calculated in the previous step. Therefore, net safe bearing capacity is equal to Q suffix NF divided by factor of safety. Q suffix NF is 2035.26. Factor of safety as he has given in the problem, it is equal to 2.5. Okay. Therefore, net safe bearing capacity for the stiff footing is how much? 814.10 kilonewton per meter square. In the same steps, you have to solve for square footing and circular footing. Here is the formula for square footing. So I copied the same formula here. 1.3 C into N suffix C plus gamma D into N suffix Q plus 0.4 gamma into B into N gamma. All the data is available. Here also you can consider C is equal to 0, B is equal to 1.5 because it is an square footing. For square footing, given the dimension 1.5 into 1.5. Therefore, B is equal to 1.5. C is equal to 0. Substitute all the values, calculate ultimate bearing capacity, then calculate net ultimate bearing capacity, then calculate factor of safety. So finally, safe bearing capacity is how much? 755.45 kilonewton per meter square for square footing. Similarly, repeat the same steps for circular footing. So this is the formula for circular footing. So 1.3 C into N suffix C plus gamma into D into N suffix Q plus 0.3 gamma into B into N suffix gamma. So here also remember, here B stands for diameter of the circular footing. Therefore, what is the diameter of the circular footing? So in the problem only said that diameter of the circular footing is 1.5 meter. Therefore, here B you have to substitute diameter, and remaining all other values, you know what you need to substitute. Depth is 1.5. So you just substitute all the values, calculate what is ultimate bearing capacity. So once ultimate bearing capacity is ready, calculate net ultimate bearing capacity, and finally net safe bearing capacity is given by net ultimate bearing capacity divided by factor of safety, that is 2.5. For 697.46 is the net safe bearing capacity of the soil, and this is how you need to calculate bearing capacity of the soil by using Terzaghi's equation. Guys, I hope all of you understood today's class. In the next class, I will come with some more problems which is very important for the exam. Thank you guys. We will meet in the next session.